welcome to thedeciphers.org. My name is Cordelia Kataria and I am a 9-year-old computing explorer and problem solver. So I got a 9 on my GCSEs and right now I'm doing my A-levels. So now what we're going to do is a modelling with Trig. We're going to do A-level revision and this week is going to be about modelling with Trig.
Yeah, that's right. So my name's Isaac. I'm an experienced maths teacher and I'm helping out with the Deciphers.org in delivering these free A-level workshops where each stream tackles a different topic in the A-level syllabus. Mostly focused on the LXL syllabus, but it's could be applied to other exam boards as well. And as Cordelia said, we're looking at modelling with trigonometry today. So our last stream that you can watch on the channel was some trigonometry where we did equations and identities, and we'll be using some of the similar skills that we covered in that session in this one. But we're going to be looking at particular questions that involve modelling, applying it to sort of real life examples. So how can people interact with this session, Cordelia?
So people can interact by writing something in the chat if they have an idea of how to solve it, or something like that.
Yeah, brilliant. Yeah, so if you have an idea how to solve it or an alternative method, then drop it in the chat. If you have any questions you want us to explain again, just put it in the chat and we'll answer it. Okay. So the way these sessions work, we go through a quick sort of summary of the stuff you need to know for this topic, and then have a go at a few questions. So Cordelia works through the questions, and I offer a few hints and advice on the way, talking about what the examiner would expect to see to pick up those marks in an exam, and then we've got a good challenge question at the end as well. So we'll firstly just go through a quick summary of what you need to know for these questions. So Cordelia, do you mind just zooming in a bit, because I think it's quite small for the viewers.
There we go.
You're able to zoom in?
Yeah.
Yeah. Okay, so sometimes in an exam or a question you might be given an expression or an equation that has a sine x plus b cos x or something similar. So a sine function plus a cos function where the angle is the same. It could be 2x, 5x, doesn't matter, but as long as the angles are the same, you can apply something that's sometimes called the R formula, sometimes called harmonic form, and it makes the most of the compound angle formula that we talked about last in our last video. So if you need to revise the compound angle formula, go back and watch our previous session where we covered that. So if you had a sine x plus b cos x, you can express that as r sine x plus or minus alpha, so some angle alpha and some constant r. Or if it's a cos x plus or minus b sine x, you might choose to do it as r cos minus plus alpha. And that's going to be really useful because it helps us do a number of things. So Cordelia, can you think of an example of something it might be useful for to get it into the form r sine x plus alpha or r cos x plus minus alpha?
So it could be helpful for like solving an equation of that form because when you've got it as r sine of x plus or minus theta, then you can easily solve an equation.
Yeah, brilliant. Yeah, so solving an equation is exactly an example of when it would be. So if you had a sine x plus b cos x equals a constant, then no easy way of solving that other than necessarily putting it in this r sine x form, the r form, or sometimes called harmonic form. Another really useful for what it's used for is putting it as is to find the maximum or minimum without differentiation. Okay, because once it's r sine x plus minus alpha, it's just a transformation of the sine graph. So it's going to be easy to stretch it or translate it to find the minimum and maximum values, which is what the modelling questions are used quite a lot. Okay? So to not rely on differentiation. So the procedure we go to get into this form is you expand the r sine x plus minus alpha or r cos x plus minus alpha using the compound angle or the addition formulae and equate it to a sine x plus or minus b cos x. And then you compare coefficients to set up two equations in terms of r and alpha. And then there's a couple of tricks that you can do to solve these using simultaneous equations quite easily, and we'll show you those tricks when we go through a few examples. And like that, this method is going to be really useful for solving those modelling type questions. They come up in exams like near enough every year, where you're given a function, you need to get into this form, and then you're asked things about maximum and minimums and solving an equation. So that's the sort of thing we're going to be looking at. So the maths is going to be pretty much the same throughout, but what's going to be important and we'll be talking about as well is how we can apply the maths to these real life questions, these modelling questions, to get those marks in an exam. So without further ado, we'll get started on the first question.
So for part A, express 10 cos theta minus 3 sin theta in the form r cos of theta plus alpha, where r is more than 0 and a is between 0 and 90 degrees. Gives the exact value of r and gives the value of alpha in degrees to 2 decimal places. So let me just...
Yeah, so a lot of the time in exams they'll give you the form of they want which one, so we could actually use our sine theta plus or minus alpha in this, and we still end up with an equation that you can solve, but obviously the masking, you want to be able to do it to the masking, so that's why they normally just give you the first the form that they want it in. So in this case they want you to use r cos theta plus alpha.
1 second, can't get there. Okay, so then r cos of theta plus alpha. Well, so if we use the addition rule, then the rule for cos, and we want to get in cos and sine that's sine squared sine of a cos b minus sine of b cos a. Then
that sounds more like the additional formula for sine.
I meant sine a sine b the other way, cos a cos b cos a cos b minus sine a sine b.
Yeah, that's right.
So cos theta cos alpha minus cos
Sine.
minus sine. I'm going to do it in the next line, just make sure you can see it. Minus sine theta cos alpha.
Yep. Times all of that by.
And we multiply all of that by r. Then, yep, like that. So that is r cos of theta cos alpha, and the minus sine theta sine alpha then if we compare the coefficients we get r cos theta cos alpha is 10 r sine of alpha is that is minus that's positive 3.
Yeah, it's positive 3, which is why they're giving you cos theta plus alpha, because of the negative 3 sine theta in the original question. Yeah. Okay, so now we get these simultaneous equations, and this is where we can apply a couple of little tricks to help us solve them.
Yep, and for this, we can just divide r sine alpha is 3 by r cos alpha is 10. And
Brilliant.
so because sine and cos is, because the r's just cancel, and sine and cos is tan, we get tan of alpha is 3/10. And then that's the same as, so then alpha is the tan minus 1 of 3 in 10. And that is I think I forgot to bring my calculator again.
That's okay, I've got mine somewhere, yeah. So tan inverse of 3/10, what are we working, degrees or radians?
So we're working in degrees because it says between 0 and 90 degrees.
It's 16.7 degrees.
Yeah. 16.7 degrees.
Okay, so we use our one trick there to divide into two equations to get in tan alpha. What's the other trick? So we could substitute that back in to find that, but the fact that you forgot your calculator quickly means that you can't sub it back in. So I'll use it in a different way, using another trick.
And also it says to 2 decimal places. Okay.
We did say 2 decimal places. 70 is 16.70.
16.70 degrees. Okay, and then we could also
So without substituting it in, how could we find r without substituting alpha? Because you can find r before you find alpha.
I'm not sure.
You're not sure? So if you had, right, it's just at the top. So if you had r sine theta equals a, and r cos theta equals b, if you squared those two equations and added them together, you'd get r squared sine squared theta plus r squared cos squared theta equals a squared plus b squared. And if you factorise out the r squared, you get r squared times sine squared theta plus cos squared theta.
And that's 1.
And that's 1. So you end up with r squared equals a squared plus b squared. So we could use that idea, and that always works. So when you have r sine theta equals a and r cos theta equals b, you can use that trick. I mean, you can find r without finding theta first. So it's just a result from Pythagoras.
Yep. And r squared sine alpha is 3. r squared sine squared alpha is 3. R squared
3 squared. Remember, you just squared both sides.
3 squared is, and that is 9. Next, there then, and r squared cos squared of alpha is 10 squared, which is 100. And then if we add them together, then r squared times sine squared plus cos squared of alpha equals 109. So r squared is 109.
Good. And it asks for the exact values of r.
R is square root 109. Let's just square root 109. And for part B, it says the height
Yeah.
above.
So make sure, have you written your final answer in the right form? Yeah, because we're going to use it in a second, so maybe just write it underneath the question, and then we'll use it for the next part. So just write it here, maybe.
Second, so root 109 cos of theta plus 16.70 degrees. Okay, so then the height above the ground, h meters off a passenger on a Ferris wheel, t minutes after the wheel starts turning, is modelled by the equation h is a minus 10 cos of ATT plus 3 sine of ATT, where a is a constant. Figure 3 shows the graph of h against t for 2 complete cycles of the wheel.
Brilliant. Yeah, so this is now, so we've done the maths part, now we've got to, we're still doing quite a bit of maths, but now it's becoming one of those modelling questions. So we've got our, notice how it's h includes our bit from part A, but it's minus 10 cos AT plus 3 sine AT, so it's a little bit different. We're also given that the initial height of the passenger above the ground is 1 metre. So we use that information to find a complete equation for the model. So in other words, find that missing constant, and maybe use our answer part A as well, to then hence find the maximum height of the passenger above the ground.
Yeah. So for part I. Okay, so find a complete equation. So h is a, and then we worked out that 10 cos 83 ATT minus 3 sine ATT is root 109 cos of theta plus 16.7 degrees. So all we have to do is to just do that with a negative and using ATT instead of theta. So a minus root 109 cos of theta plus 16.70 degrees.
Good, yeah. Now, so how are you going to use that initial height?
I went 30t. Okay, so then the initial height, they'll tell us what it is when t is 0.
So you're going to put t is 0 into the equation you just wrote in?
No, we're going to do it in the starting equation because then it's easier to sub it in because it's because we know what cos of 1 is. Wait, actually it's ATT. Yeah, we know what cos of 0 is, and we know what sine of 0 is too. So
Brilliant. Yeah. Well spotted. So a lot of people might try and put h equals 1 and t equals 0 into the equation that Cottilli's just written, but no, Cottilli is exactly right to just substitute into the original equation, because when t is 0, that you can easily work out what cos of 0 is and sine of 0.
yeah, and it is a minus, 1 equals a minus, then 10 cos of ATT plus 3 sine of ATT. So that is, well, cos of 0 is 1, so that's just a minus 10. So a is 11.
Brilliant. So our complete equation is h equals 11
minus root of 109 cos of 30t
ATT.
ATT
No.
plus 6. Wait, is it plus or minus? I think it's plus.
Yeah, it should be plus.
So it's plus 16.70 degrees. And we have finished our equation. Wait, no. So then for part I, whoops, need to move down, I guess.
So hence find the maximum height of the passenger above the ground. So we could use differentiation, because differentiation helps us find maximum and minimums, but it's only worth 1 mark. So that's a lot of effort for 1 mark. Our formula, our harmonic form, what we've just done, should be able to tell us the maximum height just by looking at it.
So we already know that the maximum value of cos of anything, whether it's t or 2t or 2t plus 60 degrees, it's always a 1. So we can just replace cos of ATT plus 16.7 degrees with 1.
The thing is, it's 11 minus something. So if you want to find, so do you want the maximum value of cos there to get the maximum overall?
No, you want the minimum because it's actually the cos term is negative, so we can just replace it with minus 1.
Yeah, good. So if ever we're finding a maximum, we want to do something, subtract the minimum.
Yeah, so it's 11 plus square root of 109. Yay!
Good. And yeah, and you get the marks for that. It's 21.44 if you wanted it to 2 decimal places, but 11 plus root 109 is will get you all the marks. So for part C then, find the time taken to the nearest second for the passenger to reach the maximum height on the second cycle.
For the second, so for the second cycle, then so for the second cycle, that's basically the secondary value for cos. So I guess we need to solve the equation to so actually all we need to do is, because we already know that we want that cos term to be minus 1, so cos of ATT plus 16.70 degrees, so that is minus 1. So ATT plus 16.70 is
so let's not use our calculator, because let's think about it logically with our graph. So we want the second value, for which is -1. So what's the value of this one? What's the angle there?
So the angle over there, that's 180 degrees. No, that is.
So what's this one?
And that one is that's 180, and that is that one. That's 180, so then that one is. I think it's 540.
Yeah, it's 540, yeah, well, because the period of the cos graph's over 360, so it's at 360 to 180. So that's what we need our angle to equal, 540.
Yep. Then ATT is 540 minus 16.7. That is 523.3. T is 6.54. And wait, is it? To the nearest seconds, that's just 7. Wait, T is 6. That's right, T is 6.54, which is approximately 7.
Or better, we want to give our answers to the nearest second.
Yeah,
so it's 6.54 minutes, but we're going to give to the nearest second. Because I don't think it's 6.54 seconds, that would be an incredibly quick Ferris wheel if you're only on it for 6 seconds.
Yeah. So then you can. I got my calculator back, and so what I did was I divided the thing in minutes by 60, because then I could use this button thing on my calculator to get the time, because it thinks that it's in hours, and then equals that equals, and 6 minutes, that's 360 plus plus 32.48, that's 392.48, 392, yes, just 392 seconds. Oh, okay, so we have finished. No, we've just
So what you could think was, you said a lot of people don't know about that button. So it's the button with on the calculator, and you go to see it online, but it's the one above the E and G button with the circle and the apostrophes. Yeah. So and that you can put in 6.54 and just press that button, and it's not really a time button. It's actually to do with degrees and parts of degrees. But because 60 times 60, 3,600 seconds in an hour, and there's 300, like you can see how it's related. It's a good way of converting like hours from a decimal to hours and minutes, or minutes to minutes and seconds. So you just literally type in 6.54 and press that button, and it'll give you 6 minutes 32 seconds, and that will give you, and that's enough to write. So you don't need to. It does say give your answer to the nearest second, and what you get 392 is correct, but you could also just write 6 minutes 32 seconds as well.
So then
So it's decided to increase profits. The speed of the wheel. So it's decided that to increase profits, the speed of the wheel is to be increased. How would you adapt the equation of the model to reflect this speed?
Then the equation. So if we increase the speed, then what that does to the equation is that it decreases the constant in front of the t in the cos and sine thing. So instead of cos 80t, it would be cos of something lower. So.
Oh, are you sure? So if you're increasing the speed, what's going to happen to the graph? Is it going to stretch out or sort of squish together?
It's going to be squished together.
So you're going to decrease the period, but it repeats quicker. Okay. So if you're switching in the x-axis, you're stretching by a fractional scale factor. Do you want to increase the coefficient of x or decrease the coefficient of x?
So you want to increase coefficient?
Yeah, you want to increase the coefficient of x. So the higher the coefficient of your x-axis squishes, which is a stretch in the scale factor, 1 over the coefficient of x. So yeah.
Yep.
So the idea is you want to increase the 80 in the formula. So giving an example is a really good thing. If you're not sure of how to word it in the exam, is giving an example will give you it's a good way of explaining the answer. But the idea is here you'd say increase the 80 in the formula or increase the coefficient of t. And then give an example. So like 11 minus 10 cos 90t plus 3 sine 90t would be a good example.
So either the coefficient of t would increase.
Yeah, that would definitely get the marks.
Yeah, so then next question. Modelling with Trig, question 2. So for part A it says express sine x plus 2 cos x in the form r sine of x plus a, where r and a are constants, where r is more than 0 and a is between 0 and pi over 2. Give the exact value of r and give the value of a in radians to 3 decimal places. The temperature, theta degrees Celsius, inside a room on a given day is modelled by the equation theta is 5 plus sine of pi t over 12 minus 3 plus 2 cos of pi t over 12 minus 3, where t is between 0 and 24, and where t is the number of hours after midnight. Using the equation of the model and your answer to part A, deduce the maximum temperature of the room during this day. Find the time when the maximum temperature occurs, giving your answer to the nearest minute.
Yeah, so quite similar to the previous question. You see that once you've done a few of these, they do all the same sort of idea that you part A is normally take this equation and put it in this particular form, this R form. Then here's a real life example. Use your answer part A to change this slightly different formula, and then use that to give the maximum or the minimum, and then find normally it's time for which that maximum or minimum occurs to solve an equation. So it's quite a similar idea from the previous question, so hopefully we could do something a little bit quicker. So part A is get that sine x plus 2 cos x in the form r sine x plus alpha. So notice it's sine x this time rather than cos. So different compound level formula, but the method is essentially the same, but we're in radians this time.
Yep, so r sine of x plus alpha, then this boundary is so r sine of x plus alpha, that's the same as r times, and then then sine of x with alpha, that's the same as sine cos x sine A plus sine x cos A.
Yeah, that's right. It doesn't really matter because it's an addition, but all the signs there are addition. But I would have done sine x. It doesn't matter. So keep going with what you're doing. But I would have done sine x cos alpha plus cos x sine alpha. But like I said, it doesn't matter. It's actually the same thing. So let's set up our two simultaneous equations.
So it's sine x. So we want to express sine x plus 2 cos x. So it's it's r sine x cos A first. So r cos A is, and then the coefficient of sine of x is 1.
Good. R cos alpha equals 1.
Yeah, and then for
and r sine alpha equals.
And r sine alpha is 2.
Good. Now let's find r first this time, but don't worry about showing all the working out because you can the exam board and the marks scheme sort of just expects you to be able to just use that trick, that squaring it and adding together trick to in one step. So you showed all the working out in the last question, but you can just go straight to how to work out r first.
So that's r times sine squared alpha plus cos squared alpha.
Remember it's r squared as well.
Yeah, it's r squared. And that is 1 squared plus 2 squared, which is 5.
Yeah.
R squared is 5. R is root 5, and it says the exact value of R, so it's root 5. And then for alpha, and sine alpha and cos alpha, that is 2. Tan alpha is 2. So alpha is 63.43 degrees.
You'll remember in radians this time.
Oh yeah. So let's rub that out. Okay, so it's in truth sometimes angle unit radian. So then it's shift tan 2. That's 1.1 and then 1.11
Okay.
1.107.
Yeah, so dividing our sine alpha by our cos alpha, we get tan alpha equals 2, tan inverse arctan of 2, 1.107.
Yeah.
Two decimal places.
And for part B, the temperature inside a room on a given day is modelled by, wait, I already read it, so for part B, right, so we have to find the maximum temperature.
Yeah, so maybe let's rewrite our model, our equation for theta.
Right, so then that's root 5 sine of x plus, and then alpha was, and alpha is 1.107. So then that is 5 plus, so theta is 5 plus, and then sine equals 5 plus root 5 sine of pi t and 12 pi t and 12 plus
Yeah, well, remember that you changed the angle.
0.107. So
What about -3?
so what, -3?
So in the equation it's sine pi t over 12 take away 3.
Yeah. So then it's -3 plus that, so then minus 1.892. 1.893, I mean. Okay. So then you have to.
Just a reminder, if you're watching and you've got any questions, do just shut them in the chat, or if you have a different way of solving them, do just ask anything in the chat.
So the maximum value of the sine term, well, that's pretty easy. It is 1 because it's a plus. It's 1.
Good.
So then if we put that into the whole equation, that is 5 plus root 5. Yay!
Yeah. Yeah, and again, you get the marks for that, or because it's temperature, it obviously makes more sense to think of temperature not as 5 plus root 5, but as 7.24 degrees.
Oops, and that is, it's actually in radians, so
But degree is temperature, degrees Celsius.
oh, okay, so 7.24 degrees Celsius. And for part Z.
So part C, find the time of day when that maximum temperature occurs, giving your answer to the nearest minute.
Okay, so that's we just have to solve, and it's the time of the day, so we have to use the primary value. Sine of pi t in 12 minus 1.893. That is 7. That is minus 1. Positive 1.
Positive one, yeah.
Pi t in 12 minus 1.893 is, and shift, and then the arc sine of 1, that is just 90 degrees.
Or in radians.
I mean pi and over 2.
Good stuff.
Yep, and that is pi t over 12 is pi over 2 plus, what is plus 1.893. That is 3.464. So So t is times by 12. Pi.
Yeah, so times by 12 divided by pi, and you get.
That's 13 point. Wait, how many decimal places? Nearest.
So we write it down 13 point whatever you get,
13.241.
because then you're going to change it to that. Remember, t's in hours, but you got to give it to the nearest minute. So similar to that last question, you can press that magic button.
Next, then that is 13 hours and that's 13 hours and 13 minutes. So.
And how many seconds?
And 50.62 seconds.
So we're going to give it to the nearest minute then, haven't we? So it's not 13, it's
13 and 14.
Yeah, so 13. Yeah, so the time would be.
So the time would be 13 times 60.
Oh, you did it. You did it. It's 13, 14. You did it.
So then it's 13 hours, 14 mins.
Yeah, after midnight, because it's asking for the time of day. It's not just asking for the value of t, it's asking for the time of day. So you could give it as a time like 13:14 or 1:14 p.m. Or you could say 13 hours and 14 minutes after midnight. Yeah, so with those modelling questions, it's important that everything you give is in context of the question. So just writing 13.2 or 13 hours 14 minutes might lose your mark because it's got to be relative to the context of the question, and in this case, you're asking for the time of day.
Yeah, and 13:14 was definitely not the hottest time of the day today. It was probably more like something like 9 something or 10.
Yeah, it's been a bit miserable this afternoon.
So, let's do the next question. Wait. Why is there another question 1? No, it's...
Alright, I've got a question 1. It should be question 3.
Okay.
It is a different question.
Okay, so then... just trying to find...
Okay, so let's do part A first. So, very similar before. Let's see if we can do it even quicker than we're doing the other two, because it's the same idea. 2 cos theta minus sine alpha. This time it's in the form r cos theta plus alpha. R is positive, alpha is between 0 and pi over 2, so in radians, given an exact value of r again. It's actually quite similar to the last question, isn't it?
Yep. Next then for part A. So, it's just r cos of theta plus alpha, and that's the same as r times and then cos of theta plus alpha, that is sine of cos theta cos alpha minus sine theta sine alpha.
So yeah, let's write down the two simultaneous equations.
So then r cos alpha is, and that is 2.
Good.
So r sine alpha is 1.
Good. And can you tell me what r squared is straight away just by looking at it?
So r squared is 2 squared plus 1 squared is 5.
Great stuff. Yeah, so again, using that trick that sine squared plus cos squared makes 1, and this is what the examiner expects to see, just r squared equals 2 squared plus 1 squared being 5, so r is...
So r is root 5 again.
It is root 5 again. And then what would tan alpha equal?
So tan alpha, that is just a half. So alpha is, and we're in degrees this time, no, still radians, and of a half, that is 0.464.
Good, yeah, so slightly different from the previous question because this time it's cos alpha equaling 2 and r sin alpha equaling, and the previous question was the other way around. So you still got the same value for r, but tan alpha is a half where it was 2 in the other case. So alpha is different.
Okay, so then that, then I'm just trying to get to the perfect. Okay, I'll just do that.
Okay, so we're then told, so remember to actually write down the answer to the question.
Okay.
Rather than just finding r and alpha.
So for part B, okay, so the answer to that question was.
To pi, to pi.
So for part A it was root 5 cos of x plus 0.464 degrees.
Radians.
So then that.
Good stuff. Okay, so we're then told that figure 6 shows the cross section of a water wheel. The wheel is free to rotate about fixed axes through the point C. The point P at the end of one of the paddles of the wheel, as shown in figure 6. The water level is assumed to be horizontal and of constant height. The vertical height h meters of P above the water level is multiplied by the equation 3 plus 4 cos 0.5t minus 2 sine 0.5t. T is time in seconds after the wheel starts rotating. Using the model, find the maximum height and time of t when it reaches its maximum height. So simple again, so like I said, this exam question is all taken from past exam papers in the last few years. Same, very similar each time. Just applying it to a different context.
So for that, it's the maximum value. So first, let's convert it to the form thingy we want. So 3. Then that is 3 plus 2 root 5 cos of x plus 0.464. Okay, and then
Good. Yep, so using our answer part A, good stuff. So then what the maximum height?
and the maximum height is just that as 1.
Make sure you're speaking up so we can all hear you.
So cos of x plus 0.464 is just 1, so 3 plus 2 root 5. Okay, so for part I 3 plus 2 root 5 cos of wait, actually we just need the cos part because one second, there we go. Right, there we go. It's not working for some reason. I'm just going to do full screen. And also, there we go. Okay, so for part I, cos of x plus 0.464. So we want that to be equal to, we want that to be equal to 1. So x plus 0.464 is, and then that. And then shift cos of 1, that's cos of 1 is, that's, I think that's 90 degrees, no 0 degrees, because for sine it's 90.
It would be a 0, but then if it was a 0, what would?
It would.
And remember, it's 0.5t, not x.
Oh yeah. But if it were 0, then it'd be negative.
So we can't have that, so we go to the next one. And remember, we're in radians as well.
And that's not x, that's 5t. Okay, then that is 0 or...
No, it's 0.5t, not 5t.
0.0. And then it's not 0. So it's 306, no, not 360, 2 pi.
2 pi, yeah, that's correct.
2 pi. So 6.28 minus 0.464, 2 times that is 2 minus 0.4 equals 11.638.
Yeah, so keep your answer to one decimal place, and this time we're in seconds, so one decimal place is good.
Yep, so just 11.6.
Good stuff. Yeah, that's correct, well done. So the next question, so we then start in a single revolution of the wheel, P is below the water for a total of P, capital T, seconds. According to the model, find the value of T, giving your answer to 3 significant figures. So how long will the point P be below the water for?
So we want the how long it would be less than 0. So then 3 plus 2 root 5. 2 root 5 cos of x plus 0.464.
0.5t, remember?
Yeah.
And we can use capital T now because we're solving for capital T, but you can still use that, I guess, it really matters.
It's 0.5 of that, and then that is so that is, so we can find when it is equal to 0 and then just and then just take those 2 away, and
Good, yeah.
then so then it'd be so 3. Now I mean, so cos of 0.5 t plus 0.464 is minus 3 into root 5. And something
Yeah, so take both sides divided by 2 root 5.
Something weird happened. There we go. Then 0.5 t plus 0.464 equals minus 3
Should calculate as in radians.
And it is then and that is okay, and then shift so it is 2.306, comma, and then it's for cos, I'm pretty sure it's 2 pi minus
2 pi minus that number.
So then it's 3.977. So 0.5 t is minus 0.464.
Make sure you explain nice and clearly what you're doing.
I'm just taking away by 0.464, so 2.306 minus 0.464 is 1.842. Then the other one is, why did that keep happening? And the other one is 3.513. So t is and then multiply it by 2. That's 3.684. And 3.513 is 7.026. So
Those are the 2 times at which the paddle is, the point P is equal to 0. So in between those 2 times it's going to be only.
Yep, so then just take those 2 away. That's 3.08 is 3.942, which is approximately, because it says the 3 significant figure, 3.94.
Let's just check that, because I don't think I made a mistake somewhere. The 3.977 minus 1.464 times 2 7.026, yeah, I've got that. And then 2.306 take away 0.464 times 2, 3.684, yeah, 7.
I wrote
7.02.
3.084.
Take away
I did supposedly.
3.084, isn't it? Yeah. 3.684.
Yeah.
You do 3.084.
7.6. Yeah. 0.684.
Then that would be 3.34.
Yeah.
Good stuff.
3.34. Okay.
Yeah, and quite common in these the modelling questions is sort of explain how question or explain what might be different in a certain situation, how it might affect the model. So in reality, the water level may not be constant. Okay, the water may rise and decrease. So explain how the equation of the model should be refined to take this into account.
Right, so then we would add another term of water level so so for this thing it would be
how would we make sure that term varies?
And we would make it that we would add another causal sign term. I think it has to be. I think it has to be sign. Let's just add another trig term.
Yeah, well that will be true. All you need to go a bit too detail, because it could just be, it might not be another trig. It might not be in the trig term. It could be just a constant, like a variable term that's constantly increasing but still variable. So it could be like 3t, which just mean the water is constantly rising. Not a realistic model, but that would mean that it varies. So all you need to do, which part of the equation would you need to change?
We would need to change the 3.
The 3, yeah. So you say the 3 would need to vary. It would just need to vary, is all you need to say. It doesn't necessarily need to, you don't need to go into detail of how it varies, just it's only worth 1 mark, so.
Okay. Needs to vary. Now
Yeah, great stuff.
Challenge question.
Okay, challenge question. So, similar sort of idea, but one bit similar to one we've already done. With talking about water varying, talking about the tide. So we've got the height of the tide, h meters in a harbour on a certain day can be modelled by the equation ht equals 10 plus root 3 sine 30t degrees plus cos 30t degrees and t is between 0 and 12, and it's in hours since midnight. So it says find the time, I should say, find the time when the high tide and the low tide occur during the morning hours of the day, and state the corresponding depth of the water in the harbour at these times. So the reason why this is a challenge question is because it doesn't have that part A that tells you what form to get into.
Oops, so then just so beats it.
Yeah, you can go straight into 30t, you don't need to use theta in this case. You can just use 30t as your angle, because that's the angle that's in the question.
Okay, so then it's, whoops, just, 10 plus, plus, 3, 10 plus, and then it's,
10 plus r, yeah, because you're going to use one of the r formulas. Which one are you going to use?
I'm going to have a look at the notes. So it said that a sine x and so on. What's that? Oh, it didn't. Okay, so yes, I think you can. I think you need to use the actually I'm not sure because it's plus, and if it's cos minus sine, then you use the cos one, and if it's sine minus cos, then you use the sine one. So
yeah, so you can there's two you can use. You can because it's sine plus cos, you can use r sine 30t plus alpha, but you could also use r cos 30t minus alpha, because when it's the compound angle formula with cos minus that's a plus, and as you sort of would just need to change the cos and sine around in the original equation, make it 10 plus cos 30t plus root 3 sine 30t, but because it's all addition, and addition is commutative, it doesn't really matter which order.
So 10 plus, I'm going to choose the sine one. So
Yeah, that's a good choice.
Sine of 30t plus 8. And so that is that's the same as 10 plus r times sine of 30t cos of alpha plus cos of 30t sine of alpha.
Yeah.
Yep,
so we can set up our two simultaneous equations. What would r cos alpha equal?
So r cos alpha is, so that is equal to the coefficient for, that's the coefficient for sine, which is root 3.
Good stuff. And our sine alpha equals
Sine alpha is just 1.
our sine alpha is 1.
Yep.
So then we can use our Pythagorean trick to find r.
Yep, so r squared is 3 plus 1 squared, which is 4.
So r is
2. Yeah,
brilliant.
that's actually pretty nice. and then it's tan of A is 1 in root 3.
Which don't need to calculate for. Tan of 1 in root 3 is.
So that is shift on.
Yeah, I can see you using your calculator. You could have done this one without a calculator.
So 1 in root 3 is pretty sure it is.
Okay, you use your calculator. It's 30 degrees.
Okay, then.
So tan of, yeah, so alpha 30 degrees. So then we can write down our original function, ht.
So it's h of t is 10 plus 2 sine of 30t plus 30 is
So it says find the time, or it says find the tide, it's supposed to find the time,
who said sure?
for which is high tide and low tide occur.
Someone said the sure in the chat. I don't know when that was.
I think that was when we said if you've got any questions, just put them in the chat.
Okay. So there is so can for part B show that it has to wait until Greek then.
So the high tide is going to be the maximum of that function.
Yep, so then the maximum is, so we want that to be 1. So sine of 30t plus 30 that is 1. So then what we can do is just 32 plus 30 degrees is, and then that's 90 degrees. So 30 t equals 60. T is 2.
Brilliant. So yeah, 2 hours after midnight, it reaches maximum. And what will its maximum value be?
The maximum value is 10.
Good. So we can say high tide is 12 meters. No, it's not 10. Yeah, 10 so 10 is doing it anyway. 12. High tide is 12 meters at 2 a.m. And then we do something similar to find the low tide.
And for the low tide it's just minus 1. And 30t plus 30 degrees is minus 1. So 30t plus 30 is, and minus 1 is, that's 270. So 30t is 214 degrees. T is 8.
Brilliant. So it's at low tide at 8 o'clock. These are hours. And how low is the low tide?
And that is just 10 minus 2, which is 8
8, yeah, good.
meters.
Okay, 8 meters, yeah, brilliant. So it says that the depth of water in this harbour needs to be at least 8.5 meters for a boat to dock. A bore, I think it's supposed to say a boat arrives outside the harbour at high tide and needs 5 hours to unload. So the boat has to wait until 9:23 to enter the harbour. So what time does the boat arrive?
It arrives at it arrives at
So we were at that was 12 meters.
High tide, so I guess it
2 o'clock.
Yeah.
And low tide
And low tide
was 8 meters.
Yeah, and
8 o'clock, wasn't it?
8 o'clock, yeah.
Okay. So
the boat arrives at 2 o'clock.
2 o'clock, yeah. We want to know what times. We want to find the times at which the height is at a point at which the boat can leave. So when H is what?
So when H is more than 8.5 meters.
Yeah.
So then I think it's meant to be low tide because wait, no, it isn't, because it's after 5, and then so then that'll be 7. After 5 hours it'll be 7 o'clock. So it's after 7 o'clock. Oops. So sine, wait, I mean 10 plus 2 sine of 30t plus 30 is that equals not 1, that is 8.5. And then 2 sine of 30t plus 13 is negative 1.5.
Good.
So sine of 30t plus 30 degrees is, that's negative 3 over 4, negative 3/4. So 30t plus 30 degrees is the arc sine of minus 3 and 4 is minus 0.848.
3 degrees.
Oh yeah. So it's actually minus 48.59. But that's negative, so we actually want So we actually want 180 minus that, so which is 228.59. So 30 T is 198.59.
We get a secondary solution as well, and find the general solutions. Maybe that'll be a good way of solving this.
What one?
If we get the general solution to get it in terms of n.
Okay, so yeah.
So you've got 30t plus 30 degrees as your inverse sine, arc sine of minus 0.75. Yeah. And then you did 180 minus that. Yeah. I got 228.59 plus 360n, plus or minus 360n.
Okay, so whoops. Minus 8.59. 311.41. So it's that comma. Okay. 228.59 minus 30. 198. Wait. I meant 311. 0.41. 281.4.
Good, yeah, 281.4, and they're both plus or minus 360n, yeah?
What both plus or minus 360?
360n.
Okay.
Because it's the general solution for solving sine. Yeah, so the next ones will be 360 more than those two.
Yep,
Which might be useful.
yes.
Doesn't really matter for this question, but
9.38 plus or minus 120n. No, I mean 12n. And 1.8.5.
good.
6.62 plus or minus 12n. Okay.
Good. Yeah, so can it leave before 6.62? Or can it dock before 6.62?
No, because it needs to, and it's after 7, so it has to go at 9.38 because it's the
Good. Brilliant, yeah.
time. So
And then we can just convert that to hours and minutes. We should get the one that's in the question.
that's 9 hours and 22 minutes.
Or should it round up to 23?
Oh yeah, 23. Keep forgetting about the seconds thing. That's why I like to divide by 60 and then do.
Yeah, it probably is a bit more accurate. Okay, great stuff, yeah, well done. Thank you everyone for watching. We hope you found this session useful. And if there's anything that you want us to cover in future sessions, then what can they do? They message us on thedisciples.org.
Yep, and please like and subscribe. And now we will stop